Hi, a pleasant day to all. Today, we're going to continue our lesson on electrochemistry. So we are now on part 3, which is balancing redox reaction on basic medium. Okay, let's get started. So balancing redox reaction for basic. So we have also steps to take. So we have number 1, write the unbalanced equation for the reaction of write the unbalanced equation for the reaction in ionic form. Number 2, let's separate the equation into half reactions, and then number 3 is balance each half reaction. Then number 4, add the two half reactions, and number 5, add OH minus for every H plus. So if we add H plus plus your OH minus, you will have a product which is H2O or your water. And step 6 is to verify. Same steps. If you notice, it's the same steps that we made in the acidic medium, but with one additional step. Okay, let's take an example for us to fully appreciate these steps. Okay, so write a balanced ionic equation to represent the oxidation of iodide ion. We have I minus by permanganate ion, MnO4 minus, in basic solution to yield molecular iodine, I2, and manganese oxide, MnO2. So notice in basic solution. So let's do the balancing of a redox reaction. Number 1, write the unbalanced equation for the reaction in ionic form. So we can write I minus plus your MnO4 minus equal to your I2 or your iodine plus your MnO2 or your magnesium oxide, manganese oxide. Number 2 is to separate the equation into two half reactions. So let's separate. We have I minus turning into I2. And then we have MnO4 minus turning into MnO2. All right, so we have oxidation and we have reduction. So if you notice, we have from I negative to I2. So that's the oxidation and reduction to, but we can further verify later. No? So to check, let's assign the oxidation number. Okay, remember, equals to the charge same oxidation number. So you have -1 also. And here for free element, you have 0 on charge niya. I mean the oxidation state, oxidation number. And then, therefore, you can see that from -1, nahimo siyang 0. Therefore, there is oxidation happening in your iodine. From on the other hand, on your manganese, so we can see that we have your O2, your oxygen has a -2 oxidation number. So we have -2 also on the other side of the equation. And we can check what is the charge of our manganese from our reactant side and then on your product side. So we can we can solve like this now. So negative 2 times 4 plus. So you have your x here. X imuhang we denote x as the charge or the oxidation number of your manganese. So we can solve for x. So therefore your so the total charge of this must be equal to negative 1 because negative 1 man ang charge there. So solving for x, you have positive 7. So we have positive 7 here. How about on the other side? Let's see. So you have negative 2 times 2 equal to 0. 0 ang kanyang charge. And then your Mn is x. Solving for x, you have positive 4. So as you can see, from positive 7 naging positive 7 naging positive 4. Therefore, there is a reduction happening in your manganese or your permanganate turning into manganese oxide. All right. So number 3, balance each half reaction. So how do we do that? So balance each half reaction. So from I minus naging I2. So balance natin ang non-H and non-O atoms. But here we don't have we have 1 iodine atom on the left side and 2 on the right. So we need to balance that one. To balance, we add the coefficient 2 in here. So 2 on your left side and 2 on your right side. Okay, continue balancing the non-H and non-oxygen atoms. So here we have Mn1. So Mn on the other side, manganese on the other side, it also is 1. So let's continue. Let's balance O atoms. To balance the oxygen atoms, we add H2O. So there's no oxygen on either side of this equation. So no need to add H2O. Okay, so this one we have oxygen appearing on the both side of the equation. So we need to add, there's an excess of, as you try to count the oxygen, there is an excess of 2 oxygen atoms on the left side. So we add 2 H2O on the right side. So we will add 2 H2O on your right side to compensate for the number of oxygen. So we have 4, we have 2 plus 2 times 2, we have 4. Okay, letter C. Each atom, to balance the H atom, we add H plus. So in here, we don't need to add H plus because wala may hydrogen appearing on both sides of the half reaction. There's, as you can see here, we already added H2O. So there is an excess of 4H atom on the right side of the equation. So we need to add H plus, 4H plus on the left side. So we add 4H plus. All right, so letter D, add OH for every H plus. So here, we don't need to add OH because wala man na siya H dira, no? So next, here, we need to add OH for every H plus. So we can see H plus here. So we need to add OH on the left side of the equation. So we need to add 4H and add 4OH on both sides. So we have, we add 4OH and here we also add 4OH. Okay, naman kay H, you can see H plus on the both of the equation, both sides of the equation. So continue. So for H plus, we have 4OH. There is H and OH combined to form H2O. So this is the one. So you have 4H and 4OH. That is, if you combine this one, you can form H2O. So that is why you will have 4H plus 4OH. You will form 4H2O. Okay, so H2O is present on both sides of the equation. Balikta. So ito, kinumbine nila no, into 4H2O. So as you can see, H2O is present on both sides of the equation. See? So we have 4x plus 2x plus y. So I think 4x is equal to 2x. So we put this put it this way, no. So we have we denote x as your H2O, and then so we have 4x. Tapos we have 2x plus y. Then it becomes 2x plus y. No? So manipulate lang my equation, then you have 2x plus y. So therefore, so you will have 2x plus y. Diba ito? This is our y. So as is na siya, but we have remaining 2H2 at 2H2O. Okay, so moving on, the charge, let's balance the charge. In order to balance the charge, we can add electrons. So here is the charge balance. Let's check. We have 2, we have wala. So we can add electrons, determine the total charge on either side of the equation. So here we have -2, here 0. So we can add electrons since the right side is more positive here. So we add 1 electron to the right side to balance the charge. So sorry, we add 2 electrons. So we add 2 electrons. So nanakay 2 here, you also have -2. So balance ng charge. Okay. So moving on. In this equation, let's check how much will we add, how much electron must be added. So here we have -1, 0, we have 0. Sorry, we have all in on the left side. Total, we have -1. On the right side, you have 0, you have -4. Total, you have -4. So you need to add electrons on the more positive. So here we need to add electrons on the left side. Since the left side is more positive, we add 3 electrons on the left side to balance the charge. So we add 3 electrons. So we have -4 on the left side and also in the right side. Okay, so balancing redox reaction. Number 4, add the 2 half reactions. So let's add the 2 half reactions. So the electrons on both sides must cancel out. So upon adding, the electrons on both sides must cancel out. So you have 2 negative, 2 I negative, you have I2 plus 2 electrons. Then we have MnO4 negative 2H2O plus 3 electrons equals MnO2 plus 4 OH minus. Then try to manipulate the equations so that the electrons must cancel out. So we can multiply 3 in here, and then we can also multiply 2 para we will have the same, mag-cancel out yung ating electrons. So upon doing that, so we have, let's simplify further. So you have 3 times 2, that is 6i negative. Then you have 2 times 1, so you have 2MnO4. And then you have 2 times 2, you have 4H2O. And then you have 6 electrons. In here, meron ka ring 6 electrons. So mag-cancel out na yan. So tanggal na siya. Okay, on the right side, so you will have I2. Since multiply ka ng 3, so you have 3I2. And also you have, wala to, cancel na to, di ba? So dito tayo. So 2 times 2MnO2, so you have 2. 2 times 4OH, so you have 8OH minus. All right, so that's your final equation upon adding the 2 half reactions. Further, the electrons on both sides must cancel, di ba? Ito na-emphasize kanina na nag-cancel ang electrons. So number 5, let's verify atomically and electrically if balanced ba sila. So let's see. We have atomically, we have iodine. So we have I, you have 6, you have 3 times 2, you have 6. Where manganese, you have 2Mn, you also have 2Mn. For oxygen, you have 2 times 4, you have 8. You have 4 times 1, so you have 4. And then you have 2 times 2, you have 4. Then 8 times 1, so you have 8. So all in all, you have 12. You also have 12 here. So the same. How about your H? So you have 4 times 2, you have 8. And then you have 8 times 1, you have 8. So balance. How about the charge? Let's see. We have negative 1. We have 2 times 1 plus your 4 times 0 kasi wala siyang charge. And then you have total, you have negative 6 plus negative 2, you have negative 8. On the right side, you have 3 times 0, kaya wala siyang charge. Here, 2 times 0, kaya wala siyang charge. Here, you have 8 times 1. So therefore, you have negative, 8 times negative 1, so you have negative 8. So as you can see, balance ang kanyang each atoms and also the charge. All right, so we have solved the problem. So the final equation is 6I minus 2MnO4 minus plus 4H2O equals 3I2 plus 2MnO2 plus 8OH minus. Okay, so we have learned to balance the redox equation using acidic medium. So let's have an exercise. So balance the following equation for the reaction in basic medium. Can you do that? Yes, you can. Kaya. So you try to solve it by yourself, and then we'll try to see if you got the correct answer when we have our synchronous class. Synchronous meeting na to, next meeting. So I will just announce that one. Okay, I think that's all for this part 3 of the electrochemistry lecture. So thank you and see you next time. Bye-bye.